Good afternoon, everyone. I'm Shotade Olusegun. In today's video, I want us to dissect observation effect at quantum level. Well, observation effect at quantum level is something that is, quite different from what is uh, observable at classical level. And so, we have that variation and that difference, we need to actually see how we can arrive at unified solution, and that is where the unification of quantum mechanics to classical mechanics is so indispensable. And so in this video we're going to actually get the fact about measurement problem. Now the thing is, quantum mechanics or quantum theory, there we have a Schrodinger wave function. Now the wave function is designed as a mathematical tool to actually describe the behavior of particle through that wave function. So it's actually talking about the primary constituent of particle that could be described as wave. You understand? So in that case, we have that duality of particle wave pattern. You understand? So now the thing is, how can we then measure happenings at quantum level? So the problem we have, the issue we have, is that there is this measurement postulate that we have, which says that the sum of the probability we get should be updated to 1. That is, we should have the sum to be 1. So basically what that is telling us is that we have the probability of getting particle, then probability of getting wave pattern. So it's more or less like we have 50 to 50 kind of situation. So if we now have that updated to 1, which is like 100%, it means that either of the two is being subdued for us to have the totality as 1 for the other. So basically we're going to actually explore this feature in time energy wave model, but there are some things I want us to understand right before we dive into that. So we have Schrodinger equation. So what we have in the Schrodinger wave function is the probability. Well, the Schrodinger equation is a linear solution. Then what that does is that we can actually have two states, and basically if we have two states just as we have for the wave and the particle, we can sum together the two in the Schrodinger equation. But the thing is, there are some properties of this Schrodinger equation. The first one, that one has to do with the time changes. I mean, the change of time that we have in the Schrodinger equation is reversible. That is number one. And most importantly, we have the Schrodinger equation to be linear equation. That one is highly essential. And then another issue we have with this Schrodinger equation is that the probability that we have is not compatible with the update mechanism that we have in the measurement postulate, because we have the 50% to 50% kind of situation, but in real fact we either observe wave, what I mean is that we either observe wave pattern or particle. You understand? So now when we look at this, when you now look at the Schrodinger equation, it actually comes with arbitrary prefactor. which is more or less like arbitrary coefficient. And then we're going to see the value of arbitrary in this time energy wave model and see how that is used in relativity to actually get the actual measure. You understand? We're going to dive into that. Now we see that from the Schrodinger equation we have arbitrary value, which the actual value must be measured against. But the issue we have when you look at the Schrodinger wave function, we have a first order derivative for time, while we have second order derivative for space. Now there is this discontinuity in the trajectory of time to space. Basically, to me, I believe that represent Euclidean space-time, which is really ideal, because when you look at how time relates to three-dimensional space, where it's going to be discontinuous in that form, because it can actually travel uh, coherently with space. And the reason why it is that is so is because time cannot relativize space. Time can only relativize energy. That is why we have that issue. Well, there are still some other issues like the Copenhagen interpretation, which has to do with the knowledge of the observer. That is when we, look at the situation, we have the detector, which is of a classical formation. So it's more or less like a classical device. So now, how is that classical device relate to its components, like what actually make up the detector? So in that case, we have this issue of the observer and the knowledge. So the thing is, if we believe that the knowledge of the observer is the description of the wave function, so in that case we can say that then the what we'll observe can actually be updated to 1. But now in a situation where we now realize differences from the classical formation of the detector to the particle, the primary particle that make up the detector, you understand, in that case there is a huge problem. And so we need to actually connect the the difference together to come up with a solution. So we're going to look at how all those things have been dealt with in time energy wave model. And so let's quickly dive into it. Now this is time energy wave model. So this is time wave. It travels inversely to energy wave. Now this model is so powerful, and when you now look at the center, you can see that we have vertical bar, which is line. Now this line is the trajectory of time at a point where energy is being so stretched to the point that it is tend to be at zero energy state. So when there is no energy for energy, time has energy to actually traverse from the classical level down to the quantum level. Now, another important thing that we need to know is that the trajectory goes beyond the limit of time energy wave model, and here we have the mass worth of electron, and that is 9.109 times 10 raised power minus 31. So we have that in kg, kilogram. So there is another important tool that we use to actually arrive at what we have here. So basically, I want you to see this point as the real point where the real mass worth of the classical counterpart of this electron mass is situated. Electrons mass. So we have this right here. Now, the formula we use in getting this is known as formula of everything. So I call it FOE. And that is the T, the M equals to capital U M plus 4M. Now, this formula is so powerful. It's a formula that fits back on itself. And what that means is that when you use an input, let's say we use this, the mass worth of electron in the place of these two M's, then when you get output, you can as well use the output as input by putting the output in the place of these two M's to generate another output. So it's a kind of, formula that fits back on itself. Now, when you look at this formula, you see that it's somehow similar, because this formula is linear and it's somehow, similar to Schrodinger equation that allows for two, states. But the issue we have with Schrodinger equation is that when you look at this formula, it is not in form of equation. The issue we have with Schrodinger equation is that the nature of the universe is asymmetric, just as it is symmetric. So most people don't really know this. So the asymmetric nature of the universe is embedded right inside the symmetric nature of the universe. So we're going to dissect that in order for us to solve this problem. So now the issue now is, one thing I just appreciate in Schrodinger equation is that it models what could, serve as the solution, but since it's using equation, there is no way that Schrodinger equation can get to the ultimate solution. So the problem is it has arbitrary coefficient, you understand, which must be attached to the two states that must be summed together. And now when you look at this time energy wave model, we have triangle. This triangle that we have is equilateral triangle. Now this triangle, this one that travels, that is diagonal at classical level, represents the constancy of light at classical level, and this one that is diagonal represents the constancy of light at quantum level. Now when you look at this, I call this wave amplitude. The wave amplitude we have at quantum level is 5.7 times 10 approximately raised power minus 48. Now this constancy is way more than the constancy speed, or it's way more than the constant speed of light. Now that means that the effect that we have at time scaling is far beyond the constancy of light that we know. That is why the speed of light is far more faster than the speed. That is why the speed of time is far more faster than the speed of light. So people don't know that time is a real entity in the universe. And unless they know the true nature of time, we won't be able to actually get down to the real measurement at quantum level. So now, let me quickly explain this. Now, by using the formula of everything, one will put this this electron's mass, we're going to arrive at its classical counterpart, which is 2,277,250,000 kilograms. Now, this watt that we have here, this watt is situated right here. This is where it is situated in the chart. Now, the real electron's mass is actually situated outside the time energy wave constraint. Now, these are the two real mass worth that we have. So those are the two real mass words. Now, this point and this point, they are the arbitrary mass worth. They are the arbitrary mass worth. So what do I mean by that? By the time you use this classical, because the way this formula of everything is designed is that the suspension, the ideal suspension will have to be from the classical to quantum. So we use what we know to get what we don't know. But in this case, we know the mass worth of electron. We can use it since we don't know the its counterpart at classical level. So by getting this classical mass worth, we can put that back into the formula, and by putting that classical mass worth, it will actually extend, it will suspend this weak conveying force. This is the strong conveying force, and this is weak conveying force. It will suspend this weak conveying force as the value of this electron, but this value will not have dot. It will just be 9109 times 109. So basically what we're going to have, this is the suspension value. What we're going to have is going to be 5.7. Then we have zeros, zeros. And then we now have 9109. Then we have more zeros. Now at 32nd position, that is where we have this suspension. Now, for us to now move from the suspension we have is at classical level. This is from here to this point. So this suspension point is the arbitrary mass worth at classical level. Now for us to now traverse from this point down to the quantum realm, we need to manually annihilate the zeros. And when we manually annihilate this and we solve it to get the standard form of this, then we're going to get 9.109 times 10 raised power. Instead of 31, it has become 32. So this will now be kilogram. Now we can see effect of radiation on this particular value that we have. And why is it like that? And that is the decaying mechanism that we have right there. Now, since this a trajectory of time, we have to go beyond the limit of time energy wave model. There is a suspension right here too, which is the quantum suspension. So by traveling beyond the suspension, there is going to be a kind of radiation that will reduce the worth, the quantum worth, and that is how we usually arrive at decaying mechanism. So basically, because there is relativity between the real mass worth and the real classical mass worth and the quantum mass worth, the real quantum mass worth will be injected back into the system. Now this is the wave amplitude at quantum level. If we put that in the formula, we're going to get the mass worth of electron while in motion, and we can see that that is so tiny, which is 0.000000001423. That is so tiny. And then for this mass worth to be in that tiny state, it will be so unstable and it will quickly decay, and that will prepare the particle towards the singularity of the future. That is the whole system. Now what I want you to really know, the solution that we have is at this present phase. Don't forget, this is the past phase, this is the future phase, and this vertical line is the present phase. So we have reality at the present. Now what I want you to know is that this trajectory is instant. Even though this trajectory is instant, you can see that it has length. And then we can see a form of intelligence. That simply means that time has some trait of intelligence, because the time, as it's coming down, it's not even stopping at this real classical mass worth. It knows where it's going, which is to fetch the real quantum mass worth, which is the real electron's mass. So basically, what that is telling us is that the solution that will make us to arrive at the real measure of quantum, that will make us to arrive at real measure at quantum level, will be at instant speed. Now let's quickly look at where the problem is, and that is the observation effect at quantum level. Now let's get to this side. Well, this particular diagram, I have used it in one of my videos, so I'm going to use it here too. Now, the observation effect at quantum level, based on the Schrodinger wave function and that measurement postulate, by having updates to be 1, it means that the other feature is being subdued for us to have the obtainable feature. So basically, let's say here at t sub 1, we have 2 persons standing next to each other. So this, if this is the observer, and if this is what is being observed, if this person A, person B, if person A is the observer and person B is the person that we are observing, this observer will be able to measure this person B, and let's say the weight is 86 kilograms. Now at this point, because they are really at constant momentum, yes, this observer can see this, what is being observed, quite all right. Now let's say there is distance of 200 kilometers between the two, such that this person B is now here. Then this observer will now observe this person B as a dot. In that case, this person A cannot be ascertained of the real worth of this person B again, but we have the distance interval. And so now let's say this person B, let's say he worked for 4 days. So by the virtue of walking, there is no much, speed difference factor. And so this person is being observed as dot. Now, if this person B at this time, which is t sub 2, now move from this point to t sub 3, then this observer will not be able to see him again. Now, the question is this: is this person B, is it true that this person B is being contracted to be a dot? Is that the reality? Or what do you think will happen if this person A, the observer, could travel at instant speed? The reason being that it has to travel at instant speed to get the fact. Otherwise, if it is not instant, the virtue of mass accumulation when something is in motion will be added to the worth of this person. So this observer will not be able to get accurate measure of this person, even at classical level. So if this observer could travel instantly to this point, then the virtue of distance interval that could accumulate weight to this particular person's B will not have effect. And so the observer will be able to measure the real worth. Then this person will still be 86 kilograms by weight. Then the time t sub 3, can we say that for the fact that this person and this observer cannot say anything at this t sub 3, does it mean that there is nothing in existence? Well, this person B will be somewhere, but it's just that this person has gone out of the visible range of the observer. That doesn't mean that this person B is not somewhere there. That is another thing we need to understand. Now let's dissect another scenario. Let's say this person A, as observer, is observing ball that is bouncing from this bottom to the top, and the bouncing speed is so fast that this person could not measure the position of this ball. Now, I want you to see how the value of speed difference factor has narrowed down the distance, the gap. Because even what the observer could not observe at t sub 2 is what he could not observe even at t sub 1 right now because of speed difference factor. Now, the thing is this. Let's say this ball is bouncing as fast as it's bouncing. Let's say the ball now travels to another point, which is t sub 2. And now, let's say the 2 kilometer distance is covered in 15 minutes. Now, what this observer will see will be length contracted motion. So, the motion will be contracted, and in that case, that could be, the blue shift. So, what we have in the past will now be red shift. And now, if this object, the bouncing ball, moved from t sub 2 to t sub 3, then this observer will not see anything. Now, the thing is, the bouncing ball is somewhere, but it's just that it is, outside the visible range of this observer. Then now the question is this. If this observer could travel instantly to this point, what would it say? Will this observer not see the ball as it is bouncing instead of being contracted by the virtue of speed difference factor? So now these are the two major things that are causing problem. Distance can contract object, and even speed difference factor can as well contract, object. And as a result of that, what the observer observe right from the classical realm to the quantum realm will serve as illusion. But basically, we cannot call what that person observed as illusion based on what I'm going to explain here. Now, if you look at the scenario of Schrödinger cat, it says that we have, the state of cat being alive and being dead at the same time. That is the superposition. Now, the thing is, in this time energy wave model, we have something of such nature as well. So there is life and death. So right now, in the superposition, basically in this time energy wave model, there is nothing like superposition because we're able to get value, actual value for all, even the constancy of light, the value of electron in motion, and even the real electron's motion. But basically, if we were to look at this, the superposition range will be within this triangle. That is if we're to have that superposition. Now, what that superposition is telling us, if I'm to thoroughly explain this time energy wave model, we have the virtue of life by the mechanism of death. What I mean by that is that at quantum level, energy is being contracted in such a way to generate radiation, and that radiation supports mass accumulation at classical level. So the contraction is what defines the direction of time. So the asymmetric nature of the universe defines the trajectory of time. Now we can say that the time by its nature is instant, because at this point where energy is termed to be low, zero, then we have time traversing from classical down to quantum realm at instant speed. Because the value that must be obtained is of event value, and so we have even the instant of light of time speed to be lengthy. When something is said to be instant, it means that it's not going to as length. But by the virtue of event, for us to really know the trajectory of time, even in its instancy, we have this trajectory. And from that, we can get to know that the only solution to getting appropriate, measurement at quantum level is for time to intervene by its instant speed. That is the only solution, and that is why we are able to get the real electron mass at quantum level at the instant speed of time. So you understand? So that is the solution. That is the solution that we are able to come up with. But now, let me quickly explain this. It is highly essential for the arbitrary mass worth to be initiated. Now, the arbitrary mass worth is what suspends the classical formation, and that is why we have delay in time peregrination. And because we have delay in time peregrination, then we could have the past, the present, and the future. And so now there is another suspension, which is arbitrary suspension. That is what we have at this point. You can say that one to suspend the happenings at quantum level. So the arbitrary suspensions that we have, they are being relativistically, scaled to the real world. Because I've been saying it, that there is no way a point can be defined without being relativistically connected to another point. If we have a point which is evolutionary point, that is if you are to define what dimension is. So that evolutionary point cannot be defined unless we have the future point. And so when they are now relativistically connected, we can define the evolutionary point to future point, and then we can even get the get the distance and all that. So relativity is so essential, but reality comes at the point of spontaneous symmetry breaking, and at that point time travels without any restriction. It travels instantly to let us have the real mass worth. So that is that. I'm so glad that this video is quite informative and insightful. So if it is insightful and informative to you, please make sure you click the like button if you like the video for real. Then do not hesitate to share this video with your friends. We want this to travel as far as possible so that we can move further in science and technology. It's a novel discovery. I'm going to put the link to my research publication in the description below. Then don't hesitate to subscribe to this channel. If you want to get subsequent update, if you want to know the true nature of the universe, as we usually, unravel it with this latest discovery, then you will need to subscribe to this channel. So make sure you subscribe to the channel. God bless you. Thank you.